Hello guys, I am Asad. In this video I will let you know about how to get started with Arduino and ESP8266 Wi-Fi module. Here I will discuss about features of ESP8266 Wi-Fi module, its power consumption issues while using with Arduino, its pinouts. I will also discuss about how to program Arduino to handle 80 commands of ESP8266, and I will also discuss about various other 80 commands including how to make TCP IP client and server. ESP8266 is a self-contained SoC with integrated TCP IP stack used as an application processor and allow our embedded unit to communicate over wireless network. It can be used as an independent microcontroller as it has built-in Wi-Fi and 2 GPIO pins. It can be used with another microcontroller through serial communication to give a wireless connectivity to it. ESP8266 could be used to develop an IoT-based security system, smart plugs, mesh networks or wearable devices. Because of its low power consumption and a small size, it could be used to deploy any kind of IoT device. So guys, before going any further, I will request you to subscribe my channel to support my efforts. It will inspire me to make many other tutorials that will be much informative for you. Now let's discuss about its features. It has 32 bits of microprocessor. It is clocked at 80 MHz, 32 GB of instruction RAM and 32 GB of instruction cache RAM. The power consumption issues we should take care about while designing circuit to interface ESP8266 with Arduino are the maximum operation voltage and current of ESP8266 are 3.6 volt and 120.5 mA. But Arduino's output voltage and current are 5 volt and 40 mA. As Arduino voltage is greater than 3.6 volt and current is too much less than 120.5 mA. To overcome this issue, voltage regulator LM317 is used to regulate Arduino's 5 volt to 3.3 volt and its output current is 1.5 ampere, which is enough for ESP8266 to draw the current required for itself. Now let's discuss about its pin configuration. Number 1 pin is RX, number 2 is VCC, 3 is GPIO 0, 4 is reset pin, 5 is GPIO 2 pin, 6 is CHPD, 7 is ground and 8 is transmitting pin, TX pin. Now here are some details about circuit that I have used to make Arduino communicate serially with ESP8266. The basic components required for this circuit are Arduino Uno, 10 microfarad capacitor, LM317 voltage regulator and ESP8266 itself. Here Arduino 5 volt output pin is connected to the input of LM317 voltage regulator, which regulate 5 volt to 3.3 volt. VCC and CHPD pins of our ESP8266 are connected to LM317 3.3 volt output. And for serial communication between Arduino and ESP8266, the Arduino RX and TX pins are connected to the TX and RX pin of ESP8266 Wi-Fi module. So guys, now let's get to know about how to program Arduino to talk serially with ESP8266 Wi-Fi module to send 80 commands. So guys, here I have used software serial library. By using this library, you can make any Arduino pin to be used as UART. Here I have defined pin 2 and 3 of Arduino as RX and TX pin of my serial. You can use any pin here. I have serially begun Arduino at 9600 and my serial at 115200. The baud rate for serial communication to communicate with ESP8266 is 115200, but we have to change this to 9600 because 115200 is not compatible to be used with ESP8266. It gives junk data which is human unreadable on serial monitor. Now we will select the board and COM port and upload it to Arduino. Copy the AT command to change the baud rate of ESP8266, open serial monitor, paste it here and done. Now if you put the test AT command, it will give no response because previously baud rate of ESP8266 was set to 115200. So we will go back to the program and begin my serial at 9600. Now we will enter the test AT command and here is the response. When dealing with AT command, make sure that serial monitor mode is selected to both NL and CR. Now let's get to know about some AT command. The link of ESP8266 datasheet and various AT commands you can learn about are given in the description below. So, if you want to connect your ESP8266 to another network, you will enter AT command AT plus CW mode is equal to 1. This mode is called the station mode. To connect, we enter the AT command AT plus CWJAP is equal to SSID, password. By doing this, we get such response. By entering the AT command AT plus CIFSR, you can get IP address and MAC address of the ESP8266 the DHCP server of your Wi-Fi network has assigned to it. To set your ESP8266 as the access point, you will enter the AT command AT plus CW mode is equal to 2. Access point is the mode in which ESP8266 work as Wi-Fi hotspot. By doing this, you can see this FairyLink Wi-Fi network is available. This is the SSID of ESP8266 you can see on your Wi-Fi list of your mobile phone. Now if you enter the AT command AT plus CIFSR, you can get the IP address that ESP8266 has assigned to its own self. AT plus CW mode is equal to 3 is the mode in which your ESP8266 can work in both modes, station plus access point mode. Now if I enter AT plus CIFSR again after setting to station plus access point mode, the response will be the two different IP addresses APIP and STAIP. As you can see, there is no value for STAIP because till now ESP8266 is not connected to Wi-Fi network as it was disconnected before. Now by entering AT plus CWJAP command, again Wi-Fi is connected, and by again entering AT plus CIFSR, you can see both IP addresses APIP and STAIP. Now we are going to set Arduino as TCP IP server. For doing this, we have to enter AT plus CIP mux is equal to 1. This will allow multiple clients to get connected with Arduino. After doing this, we will enter AT plus CIP server is equal to 1,8080. That will set the TCP IP server on port number 8080. Now we will use a TCP IP client application. Its link is given in the description below and also in the blog. Its link is also given in the description. You can also subscribe for new tutorials related to this and other interesting topics. In this client application, we will enter the STIP as you can see on serial monitor and the port number on which we have set the TCP IP server. Remember that client device must be connected to the same network on which Arduino is connected. Now as you can see that it is connected. As I have sent 1234 from the client, it is received at the server. There is also an AT command to send data from server to client as well. The server indexes the number of clients. The client that is currently connected is indexed at 0. AT plus CIP send is equal to 0,5 means server will send 5 bytes to client 0. AT plus CIP send is equal to index, byte is its format. After entering such command, you will see the arrow sign. When you see this sign, it means that you can send data. As each character is of 1 byte, hello will be of the 5 bytes. Here you can see that data is received by the client. To dismiss the connected client, there is an AT command AT plus CIP close is equal to index, that is its format. As server is connected to client 0, it will be dismissed by using this AT command. You can also set your Arduino as a TCP IP client. Here I am using a TCP IP server application. You can get the link in the description below. Here is the IP address you can see on the mobile screen. It is assigned to the mobile by Wi-Fi network DHCP server and port number you can change. To connect Arduino with TCP IP server that we have set on our mobile phone, we will enter the AT command. AT plus CIP start is equal to TCP, IP address, port number. These IP address and port number are related to the TCP IP server, that is Android mobile application. Now here you can see that Arduino as a client is connected to TCP IP server. Now you can send data from server to the client. For sending data from client to the server, as Arduino itself is a client, there is no need of index. You will enter 80 plus EIP send is equal to 6 for 6 bytes. Arrow will be shown. In response, it means you can send data now. And data is sent to the server as you can see on server's screen. I hope you have got this tutorial quite informative. If you have liked this video, subscribe Pacolabs to support my efforts so I can make more videos like that. Thank you for watching.